Yes.
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 Okay. Hello, everyone. Welcome to the webinar organized by E3S Taste Sensitivity Working Group. I'm Iona and I'm here to support the technical part of the webinar. I kindly ask you to switch off your microphone during the presentation. If you have any questions, you can use the dedicated section at the bottom right where you can find the geometric figures called activities. Click on and go to question and answer. You have also the possibility to vote the question if you agree with them. Questions will be collected and asked during the discussion. Please don't use the chat for your questions to the speakers. The webinar will be recorded. And now I leave the floor to Rebecca Ford of University of Nottingham, who will introduce the webinar on behalf of the E3S board.
Thank you very much. Thank you. It's my absolute pleasure to welcome you on behalf of the E3S board to this European Sensory Science Society webinar. This has been brought to you by the Taste Sensitivity Working Group, who are made up of E3S members who are actively engaged in investigating the role of taste sensitivity on food preference and food behaviour. So today the group will present to you the results of a survey that was used to map the applications of methods to assess taste stimuli and markers of oral responsiveness and psychological traits in Europe. So to run through how the webinar is going to run today, we first have Mari Sandel from the University of Turku in Finland, who will present on responsiveness to tastes and somatosensory sensations, followed by Emma Freeney from University College Dublin in Ireland, who will present on responsiveness to prop. And then we have Maria from the University of Gastronomic Sciences in Italy, who will present on fungiform papilla identity. And then myself from the University of Nottingham in the UK, who will present on oral tactile acuity. And then finally, Sarah and Caterina from the University of Florence in Italy will present the results from a survey on each of the variables that we've presented that are of interest. As chair, I'll be doing my best to keep to time as well as we go through this series of presentations. So I'd first like to ask Mari if she'd be able to start off the workshop today.
No, okay. Thank you very much, Becky.
Sorry, Caterina.
Yeah, thank you very much. Just a few words to introduce the webinar and the main topic of this webinar this afternoon. Sarah, can you? Okay, so as Becky said, the E3S Taste Sensitivity Working Group aims at investigating the role of taste sensitivity on food preference and food-related behavior. And we know that individuals greatly vary for responsiveness to oral sensation, including tastes, but also somatosensory sensations, so including tactile acuity and irritation. And this individual variability also affect at individual level the food preference and food choice. And this topic is largely investigated. A lot of studies deal in investigating the association between individual variation in oral responsiveness and food preference, food habits, dietary style, and so on. But still, we have mixed results, and there is not clear evidence of the relationship between these two aspects. And among other factors, differences in methods used to measure oral responsiveness may play a role in explaining these mixed results. This is why we promoted this survey, and Sarah will talk a little bit about the dimension we investigated and the aim of the survey.
Yes. Just few words about the survey that we launched last April. We developed this survey within the working group that count at the moment around 40 members from all the different countries that are joined in E3S. And we always welcome new members, so I take the opportunity to say this. And we developed this survey to get a picture of the diversity methods at a European level. So the first part of the survey include a section on taste stimuli. So how it is basic taste and somatosensory sensations are measured, and also markers of oral responsiveness, considering responsiveness to crop, fungiform papilla density, and tactile acuity. Then there is a second section of the survey for those units and laboratories that also collect data on psychological traits, of course in connection of the taste oral responsiveness markers. So we investigated food neophobia, sensitivity to punishment and reward, sensitivity to disgust, alexithymia, sensation seeking, and other psychological traits. The question was if these variables were measured and how, and also details about the methodology used in this for this data collection. What we got was, these are the results of the first part of the survey, so the ones related to the taste responsiveness and markers of oral responsiveness. So we got responses from 8 countries and 14 laboratories. Here you can see an overview of the different laboratories that participated in the survey, providing the information about their own, how they run and they collect this data. So then we will see more in details the results of each of these part of the survey, and we will start first on from the responses to taste stimuli. So I will leave the stage to Mary Sandel, that she will start with the idea is that we will have always a member of the working group presenting the methodology, the methodological issue that are related to the variable that we consider. And then Caterina will present the results of the survey. So also showing the variation between the different laboratories. So please, Mary.
Okay, thank you, Sarah, and greetings from Finland. I'm Mari Sandel from the University of Helsinki and University of Turku, professor of sensory food science in Finland, and I promised to tell you in the beginning general things about the taste and the methodology, that how the taste sensitivity and the perception has been studied. And then I do have some examples also that about the measurements themselves, and then some critical points that what should be taken into account. And maybe better that I put my video off because my network is quite unstable for some reason now. So in general, the taste, it's good to remember and remind all of us that when we are talking about the taste, we are talking about several taste modalities, such as sour and bitter and sweet, salty and umami. And all of them have different pathways to how they are activated and how the perception is going on. They have their own receptor mechanisms. And the taste perception is not simple thing at all. It's quite complicated, and it's good to remember it. And more complicated thing is when we are studying it related to food and food perception, because food is usually a combination of different type of taste modalities. So very seldom food is only sweet or food is only salt. or salty, there are usually different kind of taste modalities that are activated at the same time. And then the fascinating thing in the food and food perception is that that same food, for example, carrot, it may be pleasant for one and unpleasant for another person due to the taste. And it's very, very exciting question that why the nature has decided that same food tastes different way to the other and to different people. So we have also these members of the taste sensitivity group of E3S. We have conducted the studies by ourselves, and there was several studies in Europe that have characterized the individual differences in taste perception. In Finland, we have the Food Taste Finland study, which is about to end now in the end of this year. It's in Italy. There is a very wonderful and great Italian taste that has been there also several years, and more than 2,200 people has participated in the taste studies as a study participants. And then in Norway, Norwegians and Nofima has been also very active in taste sensitivity. These are now just examples that what is going on around Europe at the moment regarding to the taste sensitivity. And all of these projects have shown that people are different in taste sensitivity. And then another question is that, okay, why the people are different? What is the reason for that? And I don't have answer for you regarding to that question, but it's an interesting question that why it is so that we are perceiving the taste different ways. So the fact is that we are different tasters, and then that goes to the fact that we are perceiving the food also different way. And it's important why this is so important thing. We should understand better the role of the taste in food perception and food related behavior, especially in when those strategies to rather more healthy and sustainable eating behavior are developed, like they are now developed in Europe. Could I have the next one, please? So how to measure the taste sensitivity? In general, it's good to remember that the conditions should be clear and should be peaceful, and sensory laboratory is a good example to conduct this kind of study. And then it's important in the taste sensitivity studies and taste measurements that only the sense of taste is activated. And you can see here in my slide quite simple examples, water solutions where there are taste sense. And what kind of measures have been used? The classical method is the taste threshold measures, which is the forced choice test, and it's focusing on the lowest concentration levels that can be detected. They are classically used for taste testing. Then there are different kind of scales, for example, the label magnitude scale or the visual analog scale, using for one or several samples with varying concentrations, and different scales are used for taste sensitivity testing as well. So then, in addition to scales, there need to be something to taste, and so-called prototypic testants, for example, for sweet, quite usually used is sucrose. There were very different kind of compounds that are activating the sweetness. Sodium chloride for salty, monosodium glutamate for umami, citric acid for sour. Then for the bitter taste, caffeine is used, the quinine is used, and prop is used. And about the prop, we will hear more later on in this workshop. And it's possible, and how they have been studied. They have either introduced to one part of the tongue or then as a whole mouth solution. So there are different, as you can already see, different ways to study the tastings. And what has also developed and measured that how to look at the complex data when usually there is a lot of numbers. In Finland, we have developed so-called taste sensitivity score, which takes into account all the 5 taste modalities, and then we have also used the hierarchical clustering for understanding that how the segments, how the people are different from each other. And then in Italy, in the Italian taste study, they have very, very wonderful, brand new, published this year, the intensity indices for taste modalities. So the different indices for different taste modalities. These are examples that how we are able to report the complex data that is collected with the study participants. But the next slide, please. It's good to be also critical in the data collection and the measurements. And if we are using, for example, the threshold, if we want to understand the thresholds, it's good to understand that regarding to the food-related behavior, at very low concentrations, they may be irrelevant in explaining the food perception and food-related behavior. Then the role of prop, which we are going to hear more, that it has been actually challenged quite a lot. That how useful it is to present the and explain the sensitivity in taste. But we will hear more about that. Then regarding to this, are we using the retinal testing with filter paper strips, or are we using the whole mouth testing? Maybe the whole mouth testing, and looks like that whole mouth testing is better representing the real life taste perception. And then it would be very great to have one descriptor for the taste sensitivity. It's very, very fascinating idea, and I think that many of us have a dream about it. But still, also, it's fascinating idea. More detailed results in food concept and context can be achieved by focusing on the sensitivity to taste modalities separately. It's very, very useful information to understand that if person is sensitive in sweetness, is she or he also sensitive, for example, in saltiness, and what is like the dominating taste modality in the taste profile, taste sensitivity profile of the person. So as a conclusion in my talk, which is very, we are supposed to have very short talks here, different scales and concentration level of the testants and evaluation protocols have been used in different kind of studies, and our goal is now to harmonize, and it's very important and very useful that we could be harmonizing the testing methodology for taste research. And let's hear more about that, what we have done. Thank you for your attention.
Thank you, Mari. So here in this slide, you will see a summary. Sarah, can you put, thank you. A summary of what we collect with the survey. And you can see that the most part of lab who completed the survey consider saltiness, sourness, bitterness, and sweetness. And also for measuring this sensation, there is a general agreement on stimuli used. And on the other hand, a lower number of labs are interested in measuring umami, but also in this case, the stimulus is always the same. Pungency is measured by 6 labs who participated in the survey, and also in this case, all of them used capsaicin, so there is an agreement on the stimulus. But if you look at astringency, for example, different stimuli are used, and we go from chemical stimuli, and also we have real food used to measure responsiveness to astringency. Also, we have a few labs measuring fattiness, and in this case, the stimulus used is oleic acid. And in this column, you see that the water solution, so the whole mouth stimulation, is the most popular stimulus delivery system, which is used for all these sensation, but also only for tastes are used the strip that can be on the market or lab made, and also cotton swab. But These represent only marginal, I would say, in our survey, or only marginal stimulus delivery system. In the next slide, we have some information about the general procedure. And here we see some difference according to a number of steps in the procedure. So, for example, we have differences in time, so how long subjects are requested to keep the solution in mouth, so to leave the sensation completely developed before rating, the time before rating, and we see a quite variation in this kind of timing. And also, for example, not always replicates are considered. We have 5 labs who said yes, they do replicates of this measure, and 7 they say no. And the number of replicates is between 2 and 3. And also it is important to consider the time between replicates, and that goes from a few minutes, or in other case, you have the replicates in a different day. Differences in rinsing procedure, and in rinsing procedure between series and rinsing procedure between samples. So quite a large variation in general procedure to measure taste and somatosensory sensation intensity. The most important is a difference in the scale use. You see that 6 labs use general label magnitude scale, and this scale is used with preschooler, but also with the young adults and I would say older. But still, labeled magnitude scale is used with children, teenagers, but also linear scale with children and adults, as well as category scale. And also we have other procedures such as, for example, forced choice for detection, recognition, thresholds, and so on. I think this is all for taste, right? Okay, so I leave the floor to Emma, and she will tell us about responsiveness to prop. Please, Emma.
Thanks very much. I think Marie has covered a bit of this already, but I'll just run through it really briefly. So, famously there is this wide variation in bitterness perception from these thiourea containing compounds, so PTC and prop or prop if you've spent any time in the US, they like to call it over there. Originally this was a bimodal finding that dates back to the 1930s, where they discovered that sort of through a laboratory accident, if you like, that people could either be tasters or non-tasters, and this was done using PTC. Whereas now, we're more aware that actually the perception is much more of a range, and the people can really range from anything from no taste at all to extremely bitter sensation from both of these compounds. And I suppose we all know that there's been quite a bit of research on this over the years, but back in 1994, then this led Bardashuk to coin the term super tasters, who are the people who really perceive the most extreme bitterness from either PTC or prop. Then in 2003, the underlying the underlying gene receptor for this, which is TAS2R38, was characterized by Kim, and then this really led to an explosion of studies in this area that looked at both PTC or prop perception, but then also they looked at genetic variations in TAS2R38 as well. And I suppose the reason, one of the reasons that we're all here is that these thiourea compounds, we know that they're found in very many cruciferous vegetables, things like broccoli, spinach, and so on. And so because of this, and you can just click down, because of this, there has been a really strong interest in this link between taste and diet, and BMI and so on. And I'm sure every one of us on this call has probably done at least one study, if not more, in this area. But one of the main, I suppose, findings of all of this is the results are so incredibly mixed. And I suppose, as been mentioned at the outset, really, I think one of the main reasons for this is the huge variation in the different ways in which these things are measured. So some people will measure prop perception historically, maybe on a 1 to 9 point scale. Now we know that it's probably better to use either a visual analog scale or a labeled magnitude scale of some sort, and so on. But the results, I suppose, have been extremely mixed. And then, as Marie has mentioned as well, we often look at these things in isolation. So, for example, bitterness, we give a compound in water or in an isolated sort of area, and it doesn't necessarily translate so well then when we come to look at real food products. So this may be one of the reasons that we see these huge differences as well. And then, of course, you've got the differences in terms of different cultures and what they do, whether they add salt or sugar or butter, fat, cream to certain foods as well, which in some cases can mask the tastes. And then, of course, as well, as we also know, if anyone's ever tried to feed a toddler anything, the more that you try these things, you can actually then learn to like them as well. So there's a lot of different reasons why we might see these very mixed results linking genetic predisposition to prop and taste. So I'll just get you to flick to the next slide. So prop and TAS2R38, then they're often used interchangeably, prop status or taster status and TAS2R38 genotype. And as we've mentioned there, the TAS2R38 is that underlying gene that is responsible for a lot of those differences in prop perception. So they're often used interchangeably, but actually they do measure distinctly different aspects of taste. So the TAS2R38 genotype is, what we are genetically predisposed to. But then the prop taste is actually the phenotype, and it's not that the two of them are not always necessarily exactly lined up. And then I suppose as well as this, we do know that prop perception is really, it's determined only in part by TAS2R38. And I suppose, if the studies over the years, anything from 55 to 85%, depending on what study you look at, would say that that's the amount of variation within prop status that you can actually attribute to the TAS2R38 gene. And then there may be other factors involved there as well. There does seem to be some potential, I suppose, for the CA6 gene. There's been a couple of studies, one the Italian studies, and then some of our own work in John Hayes' lab in the US would have found that the CA6 gene seems to be involved there as well, the Gustin gene. But again, they don't still fully attribute all of that variation. And then I'll just get you to go to I suppose there's a couple of transitions on this slide. Apologies now, Sarah, you're probably flicking back and forth here. But I suppose, it's been mentioned a few times that, prop perception was originally, I suppose, suggested as this overall measure of taste perception. And over the years, from all of the different studies, we've seen that it's not necessarily the best predictor of all of the different perceptions. And I just thought there's a couple of really nice images in this paper. So it's from John Hayes' lab, published last year. It's kind of old data, I think at this stage we've all seen it, but I just thought it sort of states it really nicely. So what they've done here is they've just looked at the bitterness from prop by TAS2R38 diplotype. So the AVI one that you see down here on the left-hand side, that would be typically considered the non-taster. And then if we look at the right-hand side, the PAV, that would typically be considered to be the taster. And I guess if you'd have two copies of that, then technically you might be a super taster. But if we look then at the actual individual ratings there, we can see that they're very varied. So while we do see that they are distinctly different, and you can see the p-value there is quite strong, so that within these groups the mean overall rating is very, very different, we do see some considerable overlap. So you've got some people there in the AVI group who actually are rating prop up at 70 plus, and then you've got some people in the PAV group that are rating it down as low as 20 or below. So just a really nice, I think, way to show that while the TAS2R38 gene certainly is involved, there are other factors involved as well. I'll get you to flick to the next slide then. So again, this is, I suppose, moving on from prop, just this idea of prop perception as an overall, I suppose, predictor of taste responsiveness. So we can see here on the left-hand side, what they've done is just looked at the link or the correlation between the intensity ratings for prop bitterness and quinine bitterness or quinine bitterness. And you can see that there is not a very strong, it's a strong correlation, but it's not a very high correlation. So there is some correlation there. But then actually, if we look at the underlying genotype for TAS2R38, there's no link with those at all. So, again, it's showing that while prop may be some kind of a measure of overall responsiveness, it's certainly not due to TAS2R38. And in fact, what this really, I suppose, what they concluded in this paper was really that perhaps the use of prop as a generalized measure is confounded by TAS2R38. Okay, so I'll just get you to flick on to the next slide then. So when it comes then to actually looking at prop sensitivity, so, despite, I suppose, all of the problems with it and so on, a number of studies, and our own included, have seen that there is a link either with intake or with willingness to try certain fruits and vegetables and so on. And we certainly, we saw in our own studies that while there wasn't a huge impact on actual diets in children's diets or in their overall dietary quality, we did see a difference in terms of willingness to try vegetables. So, there is some, I suppose, some reason to look at this measure, and a variety of different methods exist. And I suppose in the interest of time, I won't run through them in a whole lot of detail, but just to say that in some cases you might want to determine an individual taste threshold, as Marie mentioned earlier. You can use a range of concentrations for that, or you can use just a single super threshold concentration, or some of the Italian studies have used 3 super threshold concentrations, and then you can rate those on a scale. You can do this. Some studies would have used solutions of prop, and then some studies would have used impregnated paper discs. And again, these are really useful, for example, if you're doing field studies and you're out in schools and things. So again, there's trade-offs, I suppose, for each of the different methods that you use as well, which again leads to the fact that there's so many mixed methods out there depending on what it is you're doing. Okay, so you can flick on to the next transition. But ideally, when you do rate these things, you want to try and rate them on a GLMS, or a generalized labeled magnitude scale. This just shows what that scale would look like. And then again, I'll get you to flick on to the next slide just to explain why this really is the ideal scale to use. So again, very old work, but back in 2002, Bartoszuk had a very nice description of this. So on the right hand side, you can see the non-tasters, medium tasters, and super tasters. And if we use a 9-point scale to ask people about, or any kind of a scale like that, where you've got strong and very strong, where you ask people to rate their intensity perceptions for prop, and then you have other things rated on those same scales, what you're doing is you're assuming that a non-taster and a super taster have the same range of perception. So you're assuming that very strong for a non-taster is the same as very strong for a super taster. And we now know actually that there is quite a wide range of perception. So that's not really the ideal scale to use. And again, this may be why some of those older studies have quite different results to some of the newer ones where some of the more modern scales would be used. So if we look at the left-hand side, then we can see that actually this is showing that there is that wider range of perception, and very strong for someone who's a non-taster is actually not the same as very strong for a super taster. And so because of this, we really need to try and generalize the scales, ideally outside of a taste context. Okay, so I'll get you just to move on to the last slide then, Sarah. And so I suppose just talking about the critical aspects of the methodology, I suppose this would really be one of the critical ones for the GLMS, is that label at the top. So strongest imaginable sensation of any kind. So in some cases, some of the studies would have said perhaps strongest taste, and again, because there is this idea that it may be predictive of overall taste sensitivity, that it may not be ideal to have that label anchored to taste. So ideally you want it to be generalized outside of a taste context. And so for this reason, and again, you can just click to the last transition there, Sarah. So for this reason, in some cases, so while some of the studies perhaps might have used salt as a taste to standardize the results, ideally you want something like perhaps to play an audio tone, or even to have the person think about a sound and think of that anchor as they come to make their ratings. And then at least, you know, you're sort of minimizing that risk of that bias from generalizing within that same taste sensation. Okay, so I think that was pretty much everything that I wanted to say about PROP. So I think if you want to move on then, and we can talk about the results. Oh, okay, we kept the summary in. So wait, just summarize all that. So historically, PROP taster status has been of interest because of this link with cruciferous vegetables, and it's a genetically determined marker of potentially of taste sensitivity, although the studies now would suggest that really it's not as good for overall taste sensation. It has been linked in many studies. There are literally thousands of studies out there that have looked at dietary intake or dietary quality or BMI or a mix of all of these. The results are incredibly mixed, and you know it's due to the huge number of reasons that we talked about there at the start, but also in particular the different methods that are used as well. PROP status is not the same as TAS2 or Arthria genotype, and sometimes those are used interchangeably. And again, that can be another reason that we see these differences. And finally, just that the PROP intensity perception really it's best measured using a super threshold concentration and rated using something like the generalized limit magnitude scale. Okay, so I think someone's going to present the results then.
Okay, thank you very much, Emma. Thank you very much for your presentation and for talking about the critical aspect in measuring PROP phenotype. And we still need to learn a lot about this phenotype to understand how to use it. And yes, with the Italian Taste project, we had the chance to study the association in 1,000 people between genotype and phenotype, and we found totally unexpected results. So we have to continue in studying this interesting biomarker of oral acuity, because we still don't know. We use, but we still don't know. Yes. And okay, here are some results from the survey. And also in this case, you see about the stimulus delivery, so how PROP solution on PROP stimulus is tasted. And the most popular is again water solution, but also disc. So paper disc or paper strip lab made are used. And the strip and disc from the market are less used, and less popular are cotton swab. You can see the concentration, several different concentrations are used, and all these concentrations are supra-threshold concentration, and are used different method. Only one, three supra-threshold concentration, only one at a higher level, and so quite different methodology. And the soaking solution for disc lab made in general is 3.1 millimolar, but also higher concentration are used, so saturated PROP solution. And strip from the market are less used, and here you find some brand. The delivered amount of PROP with water solution is more or less a regular sip in all case, but even in this case, you can see that different labs use different amount. And for the size and the concentration of the disc, they are pretty constant, I would say, both in lab made and disc and strips from the market. On the other hand, we have some variation in general procedure in terms of timing of the solution in the mount and timing before rating. So different criteria are used, and sometimes no criteria are specified. So this could be pretty important. And for stimulation with the disc, and the different area of the tongue are stimulated. In some lab is stimulated the tip on the tongue, sometimes 1 centimeter from the tip, both sides, one side. So also in this case, there is some variation. You can go into the next. And yes, still for the procedure, replicates are used for the most part, from the most part of labs. The number of replicates vary across labs, as well as the interval between replicates. And there are differences in rinsing procedure between subsequent stimulation, and most important, again, we see differences in scale used for prop phenotype assessment. So 8 labs use general label magnitude scale, but 4 still use label magnitude scale. Is used also linear scale, and sometimes just yes or not response. And there are also several differences in training to the scale used. This is really important to well understand, as Emma said, the different anchors on, for example, on the GLM scale. And but training is not used in all the lab, and different training and procedure are used. And also we have differences in criteria for subject classification according to prop phenotype, to prop status. The most used criterion is the arbitrary cutoff. So this cutoff from literature, this value of intensity on GLMS scale, they are used by 6 labs. In other labs are used the limits of the percentile distribution, and a less popular solution is the intensity of bitterness from prop and saltiness from sodium chloride ratio as a classification criteria. I think this is all for prop. And now I leave the stage to Maria Piocchi from University of Gastronomic Science. She will talk us about fungiform papilla determination. Please.
Thank you, Caterina and Sara, for this invitation, as well as to E3S. So fungiform papilla are one of the 4 types of oral papilla that humans carry on the tongue, together with filiform, vallate, and foliate papilla. And these structure have been considered proxy structure for oral responsiveness quantification due to the fact that in the epithelium of fungiform papilla there are important innervation for taste, texture, and chemesthesis stimuli, as well as due to the fact that fungiform papilla importantly carry taste bud, and thus have been considered proxy structure for oral responsiveness. The number of papilla is considered as the biomarker, indicated as density, so number of fungiform papilla per squared centimeter. Typically, fungiform papilla do have a peculiar shape, so a mushroom shape, elevated one, having a diameter ranging from 0.1 to 1 millimeter, depending on subjects. And as previously mentioned, there is a great variability among individuals in terms of number Only to give you an idea, according to a recent review of literature, we found that the median and mean values of fungiform papilla vary approximately from 20 to over 100 papilla per square on the old. So that quite change a lot. And also, in terms of individual variability, the number of taste spores vary from 0 to more than 20, meaning that per papilla you may also have papilla carrying no taste bud. So if we move to the next slide, there are several approaches to quantify fungiform papilla, mainly divided into those three branches. An important relevant group of technique that may be described as filming or dynamic technique include video microscopy or confocal laser scanning microscopy or contact endoscopy. Those techniques have been extensively applied in clinical settings. They do have important advantage of being highly informative about the structure of fungiform papilla and also about the functionality, for example, enabling the quantification of taste spore or the blood innervation and so on. In terms of expensiveness, those techniques do have a limited usage in sensory studies. We rather have seen the usage of the other two classes of methods that includes basically a visual inspection of digital picture of the tongue, followed by manual quantification by trained operators that normally follow specific protocols like the Denver papilla protocol, very famous one. And typically in here you may have different type of device used for acquire the picture, like photography or even portable microscope as well. And in the last 5-7 years, we also seen the rise of new automated counting approaches. So the development of new software that basically were based on the acquisition of the picture of the tongue and the subsequent quantification. Most methods are based on basically highlighting and enhancing the the possibility of visualize and automatically count papilla that are seen as a circular element, despite papilla having on their own regularity shape. So each method has pro and contras, of course. If we move to the last slide, sorry, this is a picture that gives you an idea about the possibility of differently quantifying papilla. For example, upper you find some examples of manual quantification in specific areas of the tongue, while bottom right you find some examples of recently developed automated methods. And if we, so to conclude, there are several elements that may bring variability across the studies that dealt with fungiform papilla that we summarize in the current slide. Indeed, only to give you an idea about regarding the approach of quantification technique, those factors may bring noise indeed in establishing whether this biomarker is relevant to to significantly being linked to oral responsiveness. For example, the localization, the choice of which area on the tongue to count, or even the extension may contribute to have a different papilla count number, or even the experience of the operator counting in visual manual count may further being an element of confusion, as well as the validation of the data achieved. The equipment used may contribute to having a picture with a very diversity in terms of quality. And we should also consider the other two bubbles, so both the population composition as well as the way in achieving oral responsiveness data. Putting these factors together, this element may explain why currently studies on papilla are not yet in agreement in considering this biomarker positively, so the high numerousness is not considered as positively related to oral responsiveness. I think that's all. We can then discuss further later.
Thank you very much, Maria. And here some information from our survey. And in the first column, we see the device. So different, as Maria already said, different devices can be used for taking a picture. In all this case of the tongue, so digital camera, microscope, or also mobile phone. And the most popular way to take this picture is still dyeing the tongue with blue coloring. And the area considered for papilla counting can vary from the most popular way is considering this 0.6 centimeter diameter circle, or larger area dimensions, such as 1 centimeter, or the whole tongue, or the tongue as such, in a way. Some differences in localization of this area, so which part of the tongue is considered for counting, and you see in general is considered the tip, but in different part of the tongue. According to training of operators, as Maria said, can be important, especially when we adopt manual counting technique. 3 of labs use the Denver protocol, which is one of the most popular protocol for papilla identification and counting, but also we have other procedure internally developed into the lab. And also we have a variation in the number of operators used for manual counting. So we can have 1 operator counting several times, or 2 operators counting, for example, a couple of times. And count validation, so to see if there is an operator effect, for example, on the data we have, is applied only in 3 labs. And in 1 lab is used a kind of qualitative approach comparing different, a general consensus across different operators. And we see that the use of automated counting technique is spreading, and 4 labs use automated counting technique. And here you see the reference to the original paper who described this technique. And I think this is all according, yes. And now, Becky, the floor is yours, yes, to talk about the oral tactile acuity.
Great, thank you, Caterina. So oral tactile acuity is probably the less well known to the majority of the audience in terms of the methodologies. So first off, I just want to start by explaining why we want to measure tactile acuity. If we can go to the next slide. So it's important for many reasons, but so that we can understand if there's a variation in the population, which is not something that's extremely well reported at present. And also if this variation has any relationship with texture perception, mouth behavior, diet, liking of different foods, and then everything that we've talked about so far, so prop taster status, overall taste responsiveness, papilla counts, also thermal taster status. Potentially there's some evidence of a tactile element there driving that phenotype. age, gender, ethnicity, and personality traits. So if we move on to the next slide, I would like to summarise the methods that are available to measure tactile acuity, starting off with the two-point discrimination test. And this really determines how finely innervated an area is, and is generally used across all areas of the body. So how at what point somebody can identify two close points on an area of the skin. So it's a measure of proprioception. The next one, the von Frey fibers or von Frey filaments, are pressure sensitivity tests, where the fibers present a certain pressure depending on the load that's presented. And these, the lower end of these fibers, the very smallest fibers, are the ones that have been used in the oral cavity. And those have been used to actually assess oral tactile acuity in the literature. We've got the letter identification test, which is very much focused on spatial recognition, so the ability of somebody to be able to recognise a letter when it's placed on the tongue of varying different sizes. Then we have the grating orientation test, which measures spatial acuity. So again, we have structures that span a fixed spatial range, so they're exactly the same size, but the gratings actually vary in the size between those gratings. So smaller gratings would indicate a lower sensitivity. And then finally, we've got papilla density. So the papilla counts using very similar methods that have just been discussed are very much a proxy for overall tactile acuity, because tactile receptors can innervate these fungiform papillae. So very much a proxy measure. So we can move on to the next slide, because I think it's important to critically evaluate each of these methodologies and think about the considerations. So in terms of the two-point discrimination test, really small steps are needed to measure oral tactile acuity on the tongue. So to take it away from the skin and onto the tongue and to be able to get discrimination, literature has shown that 0.2 mil steps are needed in order to be able to get that discrimination. So we need specialised methods and instruments in order to be able to do that. With the von Frey fibers, this can be to do with the presence or absence of the stimulus, so whether or not the subject can determine if that stimulus is present on the tongue or not. But it's been found to have relatively limited sensitivity when we're thinking about the oral cavity. Another methodology that's been explored is the intensity of pressure. So when we actually apply this pressure onto the tongue, that the respondent rates the intensity, which can be a little bit challenging for them to rate when they're thinking about using the GLM scale, because it's probably quite a small proportion of that scale that they'd be relating to. In terms of letter identification, this really relies on ability to cognitively understand the letter first and then be able to cognitively relay that back. So it's not just about spatial recognition, and it does require very specialised stimuli. In terms of the grating orientation test, also requires very specialised stimuli that have to be manufactured. And also, depending on the material that's used to manufacture those gratings, really limits the sizes of these groove widths and the sensitivity that can be generated using that particular tool. And of course, there is some cognitive processing with that, because depending on what orientation these squares are placed on the tongue, whether it's in a vertical or a horizontal orientation, and then the subject's ability to be able to accurately report what orientation that's in does require some cognitive processing. Probably not as challenging as the letter identification test, but still there is some cognitive processing there. And there's, as I've mentioned, when it comes to papillae density, this is more of a proxy measure. And again, the relationship between oral tactile acuity and fungiform papillae density is still yet to be really fully understood. So I think the main consideration here is exactly what each of these methods is measuring in terms of somatosensory receptors. And that's the key thing that we don't fully understand yet with some of these methods, especially when we think about the oral cavity, and how the methodologies can be optimized to take away elements of cognitive processing. Okay, so if we want to move on to the results from the survey.
Thank you very much, Becky. And yes, as you said, oral tactile acuity is the less popular measures of oral responsiveness. So we got response only from 3 labs. The 3 labs, all the 3 use both bone fry filaments and grids because, as you said, it's not clear which is the best and what we can obtain using these 2 kind of measures. So there is a quite good agreement in terms of pressure used for the bone fry filaments. So all the labs cover only a range of the possible pressure obtained with the filaments, and the response is different. So sometimes is used the RI index, sometimes is calculate the threshold using the Staircase method or the alternative forced choice. Almost the same with grids, and in all the lab, the same grids are used in terms of dimension, in terms of distance between the grids. So there is a quite good agreement in these 3 labs. We have only 1 lab using a completely different method, but is a direct measure of responsiveness to one of texture properties, which is hardness in this case, and they use jellies with different concentrations, so with different hardness, and can measure in a way the responsiveness of subject to these specific texture properties. And this is all for the oral tactile acuity. And yes, now I leave the floor to Sarah, and Sarah will talk about the second part of the survey on psychological traits. Please, Sarah.
Yes, thank you, Caterina. I will be very short. And I also take the opportunity to say that if someone has some question, you can already ask them using the section for questions, so we can then consider them in the discussion. For this last section in psychological traits, we collected data and we received responses from 5 countries, and here you can see the lab that replied, and as you can see, the vast majority, all the labs that participated in the survey, they declared to measure food neophobia with different scale, while the other questionnaire that we included were less used. The ones that was used at least by 3 groups was the sensitivity to disgust that was measured. And also there were other traits that were measured, such as the Big 5 personality questionnaire. Here is an overview of the food neophobia that was the one that was most measured by most of all the laboratories. And as you can see, the 8 laboratories, they all use the scale that is very well known of Pliner-Obden of the 1992. And this was used in the original version once in English, and then it was used in translated, validated version by 5 labs, while there were another lab that validated the translation and another one that used a back translation, just a back translation. Here below you can see the ones that declared to use validated translation, which was the reference. And for the other questionnaire that were used was the Italian Child Food Neophobia Scale. And in this case, it was developed in Italian, but then it was validated in 5 different countries and languages in Europe by the working group, the E3S Children Working Group led by Monica Laureati. So these are already available, this translation. They make available this translation and validated version of the questionnaires for children. And then there was one mention of the food phobia test tool. For sensitivity to disgust, 2 labs declared to use the short disgust sensitivity scale. That is a very short 8-item scale, while another one used the disgust scale revised. And there was also a mention of another reference, this Amman et al. So to summarize these results, we can say that because we asked this question also to understand if there was the possibility to compare the reliability and the internal consistency of the scales translated in different languages. And the only case in which we can do it is food neophobia, because it is the questionnaire that is used by all the labs that participated, and they were all available to share the data set to compare these results. So this is something that we can do, and the next point is actually related to what's next, so we can speak about it. And Caterina, please.
Yes, what's the next? And yes, from data you know, about the question in the survey, there was also a question about the availability to share the data. And so looking at the labs who were available to share the data set and to with other members within the working group, we found three interesting areas of possible collaboration. One could be about the reanalysis of data set on prop phenotype. And we have at least at the moment 4 labs who declared that are available for sharing their data on prop phenotype. And data were collected on pre-adolescents and on adults. And could be interesting in this case to see what happens with different methodology, different training to the scale use, and to see how different procedure can impact on prop phenotype and subject classification. That is one of the important things to better understand at the moment, to use prop as a general marker of oral responsiveness. A second possibility of collaboration is about fungiform papilla density assessment. Also in this case, we have at least at the moment 3 labs interested in sharing data, and hopefully also in sharing tongue images. And in this case, we have data on papilla density assessment by manual count, but also by automated count, and different techniques are used. So seems an interesting field to explore. And finally, as Sarah said, we have this possibility of collaborating for reanalysis of food neophobia questionnaire data and to compare the consistency of the questionnaire across different languages and different countries. These are proposals, of course, they are open, and I would like to hear your voice about this this possible future collaboration. What you think, and of course, also if you have a question on presentation on other aspects, we have some time for this.
Great. So we don't have any questions coming through on the in-call messages, other than Mari's offered that Finland could participate in study 3 if needed, which is fantastic. To get that contribution. I myself am also going to double check to see if we can contribute some tongue images that we've got. So I just need to double check the ethics to see if we need to apply for additional ethics in order to be able to do that. Sarah's got her hand up.
Yeah, no, I just wanted to add that our idea was first to start with the prop and the papilla study, at least with the labs that already declared that they are willing to share the data set. Of course, the data set that will be shared should be anonymous, in the sense that we just need the code of the subjects, but no personal data should be shared. And so the idea is to work first on this and to postpone the work on the questionnaire to later, as a later step, because it's also the main focus of the working group to work on test sensitivity. I don't know if there are other groups that would like to join.
Yes, I see in the chat there are several people interested in participating in the study. So I think we will open a kind of call for a study on prop, for the study on papilla. And of course, we are completely open to collaborate with all of you that have already data and are happy to share and have their data reanalyzed and compared with the dataset from other labs. So we are very happy to have contribution from all of you. And I think can be the best they can write to us, Sarah. You can write to Sarah and myself, and you can specify which study you are interested in participating, and then we will contact you again. And yes, I think this is the best. Just to answer to Emma about the bitter stimuli, yes, caffeine and quinine were used considering bitterness in general, and prop was considered apart, not in the taste in general, but as you say, prop was considered a lot.
Yeah.
Okay.
Okay. There are also other messages in the chat. So good to see that there are many people that are willing to participate and to better understand these aspects. And probably we can also consider different age range, because at least in the one that were shared so far in the survey, they were pre-adolescent and adults on prop. Erminio raised his
Yes,
hand.
I do not have a question, but I have rather a suggestion. I think that the work that you have done in this survey should be valued, because it could be important for people to know different ways of different way to measure several parameters of taste sensitivity or oral sensitivity, what you want. So we know that periodically there are reviews, but this is a different job. I mean, it's a different work that has been done. So what currently people is doing, and so it can be very useful for readers to know what is done, what the advantages and disadvantages, also because you have been reviewing the previous paper, so it could be a quite original paper. This is just a suggestion.
Yes, Erminio, thank you. This was one of our idea, and we will think which is the best way to move the first one. But of course, it is interesting to have a review on methods in their self.
Yes, as we have seen, the things are always more complex than they look at first sight.
Well, at least we know why we have contrasting results. Yeah?
Yeah, but this should be, for sure, there is a contribution
until we do not uniform the methodologies, it could be critical to find, well, to have an important information on that.
No, the idea also of proceeding for the working group in general was to have this survey in terms of exploration of what's going on. Of course, with the review, we will get further results also, first because it's not limited to Europe, and also because there are many labs that didn't participate, even if they collect this variable. And second, with the sharing the data set, we would like to create a subgroup that work on the analysis, reanalysis, so also sharing the statistical analysis approach to compare the different results. And then finally, the third step would be to develop a common approach based on the findings of this previous step. We will arrive there. We hope to arrive there soon. I see there is a question in the chat. What taste sensitivity test do you suggest for elderly population? Is that focus of your research?
It is not needed. I can say it.
Erminio is joking. No, I think one of the labs answering to the survey, they reported taste sensitivity test on people older than 60, I think 60, 75. So nothing changed in terms of methodology, and of course there is someone, Sarah, you remember? Yes, someone who reported this kind of data with this methodology we talked about, also on elderly. I mean, if elderly have not cognitive problems, and it depends from age and health status of the elderly.
I think if there are no further questions, also because we are late compared to our initial plan, but there were many things. I think that we thank a lot all the attendees and also all the speakers that participated in this webinar, and also the people that replied to and filled in the survey that took some time to do it because there were many questions. So thanks to everybody.
Thank you, Sarah. And on behalf of the E3S board, I want to say thank you to all of everybody involved in the working group that have put together this webinar today on this really interesting topic, and are really trying to bring everybody together to work on this really important area together and get this combined consensus in terms of the methodologies moving forward. I think it's a really important area, and one that's obviously clearly generates a lot of interest by the number of people that have attended today. So thank you to everybody that's contributed, and to the leaders of the Taste Sensitivity Working Group, for all of your time, energy and effort that you put into this. So thank you very much.
Okay.
Thank you very much.
Thank you. Yeah.
Thank you.
Thanks.
So thank you again.
Thank you.
And
Bye
have a
bye.
nice evening.
Goodbye.
Bye.
Bye
Thanks,
bye.
guys.
Everybody.
Bye-bye.
Bye.
Bye-bye.
Bye-bye.
Bye-bye.